Let's return to the question of how confident can we be in the knowledge that we possess? We accept that knowledge in some areas does change, and changes quite considerably. In history, for example, you've probably heard the saying that history is written by the winners, and that those who sit on the other side of history, the wrong side of history, well, they just get written about. But when historians ask questions about these others, well, then the story can change. When they ask the question, for example, of what was it like for the working classes in the early days of the Industrial Revolution? What was it like for women in the late 1800s when they were not allowed to have a vote? What was the experience of colonisation like for Indigenous people? And then they go and follow those questions, and they try and find traces of the voices of these people and re-stitch together a different account of historical events. Well, then the story of history changes, our understanding of the past changes, and accordingly, so too does our understanding of the present. What can we say about the natural sciences? Well, thanks to the scientific method, we are pretty sure about a lot of the things in our world. We can be pretty sure that water boils at a certain temperature, and that the world is roughly spherical. However, when we're using the scientific method, we are always making general statements about the world and the stuff that is in it on the basis of a limited set of observations. And there's always the chance that we might miss one exception. A classic example of this occurred over 200 years ago. In Europe, all observed swans were white. So if you were using the scientific method, and you went out and you observed as many swans as you could possibly see, under a variety of conditions, you would be justified in coming to the conclusion that all swans were white, because every swan that you would have seen would have been white. Then, in the late 1700s, Europeans arrived in Australia, and there they found black swans. This is why scientists usually talk in terms of things being probably true, rather than certainly true, because you can never really know for sure. Secondly, there is an assumption underlying the scientific method that the future will, in its most significant characteristics, resemble the past. This is based upon the view that the natural state for any natural system is one of stability, such that if it does get disturbed, it will return as quickly as possible back to its original state. This view is being challenged by science itself, in particular by the new complexity sciences. What these sciences argue is that the natural state of most natural systems is one of change. They're dynamic. They are constantly altering their configuration. These scientists view natural systems as complex sets of relationships between a wide number of elements. Think, for example, of an ecosystem, such as a rainforest. It comprises plant life, animal life, microbial life, the chemical composition of the water and of the soil, the climate, and these are all interrelated with one another. If one element changes, well then that change ripples through the whole system. It changes the relationships with everything because everything's connected up with one another. We may not necessarily notice these changes, but you get a sufficient number of changes, they edge the system closer to what is referred to as a tipping point. That is the point at which it flips over and takes on a new state. So, for example, our rainforest might find itself suddenly turning into grasslands. So we can have a situation where a large change may occur in a system that is quite some distance away from its tipping point, and it won't have much of an impact. However, we can have a small change in a system that is very close to its tipping point, and this is the trigger for the system flipping into a new state. This is what Lorenz was referring to when he used the metaphor of the butterfly effect, the metaphor of a butterfly flapping its wings in South America, the displacement of the air rippling through a range of complex systems all the way through to the point where a typhoon hits the coast of Japan. What the complexity sciences are also drawing our attention to is the way that it is increasingly difficult to think of natural systems as separate from human systems. What human beings do impacts upon natural systems, and they react in ways that we cannot always predict. We are probably more aware of this in our time and place, because we live in a world in which we know that medical science can provide all sorts of wonderful vaccines against microbial infections. However, the microbes themselves, in response to our interventions, may mutate, and all of a sudden we find we've got superbugs and a great epidemic on our hands. We also have an understanding of the way that science itself, by way of technology, enabled massive advances in the capacity of human beings to produce things, the Industrial Revolution. However, in powering these systems, we've altered the chemical composition of the atmosphere, and now the climate itself is changing, and we're not sure just what is going to happen. So scientists nowadays will often talk less in terms of predictability. They will not make predictions, but what they might do is map out various scenarios. This could happen if something else happens, but then something else may happen as well.